Okay, so you guys learned everything that you needed to know from 5.1. So now we're going to focus in on a little bit more of, instead of the radicals, I mean, we'll still talk about those radicals, but we're going to talk more about scientific notation and then a little bit about exponential rules. This whole chapter 5 is kind of a hodgepodge of radicals and exponentials all together. So the first thing we want to hit up is scientific notation. So, scientific notation. Here's some information for you. Basically, it looks like a number times 10 to an exponent. A number times 10 to an exponent. What's really important that you understand is that this number has to be between 1 and 10. Okay? Has to be any number between 1 and 10. In fact, I mean, to be more specific, you are can be less than or equal to 1, your number, but you have to be less than 10. So you can't actually equal the number 10. You'll understand what I mean here in a moment when we start talking about how we convert into scientific notation. But this is really what I mean by between 1 and 10. So like if your number is 0.5, 0.5 is not between 1 and 10. You'll have to do some fixing. But 1.05, now that's between 1 and 10. If my number was 10.75, that's not a scientific notation number because the number is bigger than 10. If I had 9.89, that's okay because 9.89 is between 1 and 10. Now, just a little bit about your exponent because that's where everything kind of revolves around this guy. So the exponent is the number of times you have to move the decimal to create your scientific notation. So the reason why we talk about this exponent because there are numbers that are too large for our calculators to handle. There are also numbers that are too small for our calculators to handle. So, you know, as wonderful as what our graphing calculators are, there are just numbers that are too big and too small for it to be able to show you every possible value that is in it. So the exponent is all about that, and the exponent comes from the number of times you have to move that decimal to create your scientific notation. And again, you're going to see this in some problems that I have coming up because this whole video right here is all about creating scientific notation or taking it out of scientific notation back to the standard notation, back to the original number. So a couple things again about that exponent. If it is a positive exponent, that means that the number that was created or where it came from was very, very large. And just so you know, positive exponents, which is really important here, is when you move the decimal to the left. Anytime you move a decimal to the left, you are creating positive values for that exponent. Okay, think about kind of like adding. Anytime you move the decimal to the left, we are adding on to that exponent. We're making it bigger. We're making it more positive. Okay, and vice versa. A negative exponent means that the number is very, very small, like 0.000000000001235. Okay, that's a very, very small number. And again, for those negative exponents, it comes from you moving the decimal to the right. Anytime you move the decimal to the right, it's kind of like you're subtracting from the exponent. You're making your number smaller and smaller and smaller and smaller. Okay? Because you're moving to the right. We are subtracting from that exponent. So this is all very, very key for you right in here. Remembering that when we're dealing with positive exponents, we're talking about moving the decimal to the left. When we're dealing with negative exponents, we're talking about moving the decimal to the right. All to create this number that has to be between 1 and 10. So let's do some conversions. So here I have some regular numbers. I have a really, really small number, which is the 0.0000375, and I have a really, really large number, which is the 293 million that I have down below. We're going to turn these into scientific notation. So everything is about moving the decimal. Again, if I move to the left, I'm creating a positive exponent. Or think about like I'm adding. If I'm moving to the right, I'm creating a negative exponent. And it's all about creating that number that is between 1 and 10. So let's do some moving. So here's my decimal right here. I need to move it to the right, because I got to create a number between 1 and 10. So if I move it 1, that number is not between 1 and 10. I still have to keep going. If I move it again, it's still not between 1 and 10, so I keep going. I move it a third time. I'm still not between 1 and 10, but I'm getting closer. I move it a fourth time. 0.375 is still not between 1 and 10. So I'm going to move it one more time. The number 3.75, now that is a number that is between 1 and 10. And then I set up my times 10, and all we got to do now is fill in the exponent. We moved to the right. So that means my exponent is negative. How many times did I move to the right? 1, 2, 3, 4, 5. So it is a negative 5. There is the scientific notation for that really small number. The same thing's going to happen when we work with the really large number that we have down here. Here is the decimal. I have to keep moving it until I get a number between 1 and 10. Nope. 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 No. Yes. 2.93 is between 1 and 10. And then you add on that times 10. And again, this time we move to the left. So that means my exponent's going to be positive. How many times did I move to the left? 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is a positive 8. And there it is. That's how you convert numbers from standard notation into scientific notation. It is that easy, guys, I promise you. Okay? So let's reverse the idea. Let's say this time I give you scientific notation, and I want you to take me back to the original. Okay? So, look at your exponent. It's 4. That means that I need, and it's positive, that means that my number is going to be a large number. Anytime you have that positive exponent, remember that means it's a large number. That means that this decimal came from the right. Yes, it came from the right and moved to the left. Sorry, I had to think about that for a second. So that's what it's talking about. It came from the right. So let's take 1.25 and undo the movement of 4. So we're going to go 1, 2, 3, 4. There's where my decimal's at now. What do I do with all these hoops that do not have numbers in them? Well, just remember that represents 0 now. So what is the actual number? 12,500. 1.25 times 10 to the 4th is really the number 12,500. Looking at the next guy. Our exponent is negative. That means that our decimal came from the left. It was moving this way. Okay? So we need to undo that movement from the left. Oops, too far, too close, because we've got to move back to the other side. So we're going to grab this guy and we're going to move it 3 because our exponent is negative 3. 1, 2, 3. Remember, with a negative exponent, that means you're creating a smaller number. It should be a decimal number. So here's where my decimal point is now. Again, with all those extra hoops, we just tack in the zeros. So what is the real number for 7.6 times 10 to the negative 3? 0.0076. So I have 4 problems that it is now your turn to try. I feel like I skipped something. Nope, I didn't. Yeah. Sorry about that. I thought I had a slide in here that says your turn, but I didn't. So, but it is your turn now. So here I've given you a small number. I've given you a large number. I've given you 0.000000134 and 75 million. Go ahead and convert these to standard notation. Try it. Okay, so we're going to move our decimal 1, 2, 3, 4, 5, 6, 7. So the number that you should have had in front was 1.34, and it is times 10 to the negative 7 because it was a small number. Negative exponents are for small numbers. The guy down below it, here's our decimal. We're going to move it 1, 2, 3, 4, 5, 6, 7. So we get 7.5 times 10 to the positive 7, because positive exponents are reserved for large numbers. So there's your scientific for those. Now, I want you to reverse it. So give it a shot. Take 1.25 times 10 to the 4th, change it to standard notation, and take 7.6 times 10 to the negative 3, change it to standard notation. Okay, so 1.24, because it's a positive exponent, we got to undo the movement from the right. So we went 1, 2, 3, 4. So there's our decimal. So what is our number? 12,400, because we put zeros into those extra hoops that didn't have a number. Down below we had 7.6. The decimal came from the left, so we're going to undo that with 3 movements. There's my new decimal, so that gives me 0.0076. So there is the original number. All right, so welcome back. So this guy, we're still talking about scientific notation, and we're going to do some operations. We're just going to do the basics. We're going to do adding, subtracting, and we're going to do multiplying and dividing. Okay, so again, I have roughly about the same amount of problems that you saw in the last video. We got 2 adding, subtracting, we've got 2 multiplying and dividing, and then I'm going to have 4 problems for you to try on your own. Okay, so let's get started. So adding, subtracting. So there's some things that I want you to keep in mind. So in order to add and subtract 2 scientific notation values, you must make sure that the times 10 to the exponent piece matches. Okay, if they do not match, you cannot add and subtract them. Okay, if they do not match, you cannot add and subtract them. So you'll have to do some fixing to that if that occurs. You'll have to do some fixing. So we have to make sure that it matches. Okay, it's kind of like combining like terms, as long as they match. So if they do not match, then I provided you how to fix that. If they do not match, you will take the lowest times 10 to the exponent and raise it up to the highest guy. So all we're going to do is simply just move the decimal to the right. Move the decimal to the left until we get to the exponent that we want. And every time we move to the left, we add on to that exponent, because moving to the left means that we're making a bigger number. Okay? So again, if they do not match, you're going to take the lowest times 10 to the xp, and you're going to raise it up to the highest. And again, all you're going to do is move the decimal to the right. Left. Keep saying right. Move the decimal to the left, and that will add onto your exponent. Okay? And then, once you have that, once they are the same, it's really easy. All you're going to do is just add or subtract the 2 numbers. Of course, in the end of this, because we are adding and subtracting, something could happen where you might not be in scientific notation anymore. If you're not in scientific notation anymore, then we need to make sure that we fix that. Okay? So, just to recap again, when we're adding, subtracting, super easy. We have to make sure that the times 10 to the exponent matches. If it doesn't match, we take the lowest and we bump it up to the highest by moving the decimal to the left, which adds on to that exponent. Once they match, we add and subtract the two numbers together for the scientific notation. And then in the end, you got to double check your answer and make sure that it is still a scientific number, scientific notation number. In other words, you have to check the 1 through 10 number. You got to make sure that it's still 1 through 10. Okay, so let's start taking a look at adding and subtracting. So here we have two numbers that we want to add and subtract. Okay, notice that the times 10 pieces do not match. So we need to take the lowest guy, which in our case will be the 10 to the 3, and we need to raise it up to the 10 to the 4. How did I say to do that? Take your decimal and move it to the left, which will create a new number. 0.23 times 10 to the 4. Because again, remember I said that if you move to the left, you're creating a larger number, which adds on to that exponent. And now, the pieces match. I have times 10 to the 4th times 10 to the 4th. So all we have to do now is take care of our two numbers, 0.23 and 1.65, by adding. So if I add 0.23 and 1.65, I get 1.88 times 10 to the 4th. You don't change the end piece. Do not add those exponents together and say it's times 10 to the 8th. That's not what's going on. And there it is. And of course, that is our answer because this number right here, the 1.88, is still a number that's between 1 and 10. If that number was not between 1 and 10, we would have adjusted it. Okay? By moving the decimal to the left or to the right. So again, we're down here. We're doing some subtracting. Again, we do not match. So we need to take the lowest guy, which in this case is the times 10 to the negative 5. Remember, the larger the negative number, the smaller it is. That's why it's times 10 to the negative 5 is our smallest guy. And we're going to adjust this. Remember how to adjust it. We take the decimal and we move it to the left. And so that gives us 7.4 times 10 to the negative 4 here. And we're going to subtract 0.36 or 0.36, however you want to write it, times 10 to the negative 4. Because we moved that decimal to the left, we added onto the power. We raised the power. It's a larger number now. So, since we match, all we have to do is the subtraction of the 7.4 minus the 0.36. And when you subtract those, you get 7.04 times 10 to the negative 4. Again, the exponent on the times 10 to the negative 4 does not change. It's like combining like terms, like what I said. Okay, so that's adding and subtracting. That's really that. It really is that easy. As long as your times 10 to the match or to the exponent match, you can just add and subtract the numbers in front. If they don't match, you got to take the smallest guy and bump it up a notch. So it's your turn. So I've got two problems here where you're going to do some adding and subtracting. So here they are. Give them a shot. Okay, so again, they don't match. So we got to bump it up a notch. Okay, this is the lower guy. So we're going to take my decimal, which is right there, and I'm going to move it to the left. So what we're looking at is 15 times 10 to the negative 3 plus 1.8 times 10 to the negative 3. Because again, we bumped it up a notch. So now they match, so we add our two numbers. And we get 16.8 times 10 to the negative 3. But now, if you look at this, and I didn't do this on our last problem, I should have. Let's go back and just talk about it real quick, since I didn't do it, because it's important. I didn't check to see if this number 7.04 was okay. And it is okay, because 7.04 is between 1 and 10. But if we look at the one that we got now, we have 16.8. That number's not okay. 16.8 is not between 0 and 10. So, I've got to take my decimal and I'm moving it to the right. To the left. Gosh, my left and rights are all funky today. So I moved it to the left. And again, anytime you move it to the left, that bumps up your power again because you're making a larger number. So that's what you're really looking at. 1.68 times 10 to the negative 2, because we had to bump up our number here. Anytime we move to the left, we add on to that exponent. So there it is when you actually add those two numbers together. Down below, we're doing some subtraction. They don't match. So we need to take our smaller guy and we got to bump it up. So we move our decimal over and we end up with 5.7 times 10 to the third minus 0.49 times 10 to the third. Now they match. Just take care of your numbers and you end up with 5.21 times 10 to the third. And 5.21 is between 1 and 10. So this answer is okay in scientific notation. All right. Let's work some multiplying and dividing. Multiplying and dividing is nice and easy. Okay? We don't have to worry about bumping numbers up or bumping numbers down to do our multiplying and dividing. So when you're actually multiplying and dividing scientific notation values, when you're dealing with the exponents, you are either going to add or subtract the values together. Okay? When it comes to the numbers, you actually do the multiplying or dividing. So when I talk about the adding and subtracting the exponents real quick, you will add exponents when it is a multiplication problem. When you are multiplying scientific notation. You will subtract exponents when you are dividing. Okay? And then always, just like with the adding and subtracting, please make sure that in the end your number is in scientific notation. So again, to recap, we don't have to do anything special here. But when we are multiplying and dividing, the exponents, they are either added together, if you're multiplying, or subtracted together, if you're dividing. And then the two numbers in front, the numbers that are between 1 and 10, you either multiply them or divide them. And always, in the end, make sure you're in scientific notation. So let's do some. So this first guy, we're multiplying. So what I was talking about a moment ago, these are my two numbers, so they're going to get multiplied. These guys are my exponents, and because we're multiplying, we're going to add them. So what do we get when we do the multiplying and the adding? Well, 6 times 3 is 18. Times 10, 3 plus 5 is 8. And as always, we need to check our number. Is 18 a number that's between 1 and 10? No. So we have to fix that. There's the decimal, and we got to move it one place to the left. And again, if you're moving to the left, you're going to add on to that exponent. So there's the real value there in scientific notation. 1.8 times 10 to the 9th. Division right here. So we're going to take our two numbers, 15 and 6, and we're actually going to divide them. We're going to take our two exponents, and these guys will get subtracted. So what do we have? Well, when we take 15 divided by 6, we get 2.5. Sorry, I didn't mean to put that extra dot right over here. Woo. It's all connected. Let's fix that. We get 2.5. That's 15 divided by 6. Times 10, we take 6 minus 4, and that gives us 2. And there it is. There's the division. Your numbers get divided, and your exponents get subtracted. So, now it's your turn. So I got two problems. One's multiplying, one's dividing. Go ahead and give it a shot. Okay. So, taking on the multiplying one, nice and quick. You're going to take 4.1 times 3.0, and that will end up giving you 12.3. We're going to take our exponents here, and we're going to add them. So we got 12.3 times 10 to the, oh gosh, I'm losing my mind, 12. So, check your number, 12.3. No, that is not in scientific notation, so we need to fix it. So we move our decimal one place to the right. Sorry, left. I'm never gonna live this down. So one place to the left, we get 1.23 times 10 to the 13th because we bumped that number up by moving to the left. Okay. The next guy, we're gonna do the same thing. My two numbers are gonna divide each other. 8.7 divided by 1.4. And you will end up with 6.21. And then we will take our exponents here and we will subtract them. Times 10 to the 3 minus 4 gives you -1. So, check your number, 6.21. Yep, that's between 1 and 10. That is the final answer. Okay, we are halfway done with 5.2. So now we're going to start getting into some of those exponent rules. And the first thing we're going to talk about is rational exponents. In other words, we're going to talk about exponents as fractions. Exponents as fractions. So, couple things. Woo, something didn't transfer over, right? Well, just kind of fixing this up. This is a square root sign. This is a square root sign. So what you're looking at is a property for rational exponents. Whenever you have a rational exponent that is a fraction, what you need to understand is that the numerator is all about the power. Like squared, cubed, to the 4th power, to the 5th power. The denominator is all about your root. Your square root, your cube root, your 5th root, okay? So that's what you see right here. My numerator was A, so I put it in a power position. My denominator was B, and I put it in the root position, okay? There are two different ways that you can write this. So you see it up above where we actually have the root that overtakes the power, or you can write it down below where you have the root being taken to a power on the outside. I generally go with this form that's right here. But again, you see that the root, the denominator, is right there, and it's on the inside of my parentheses, and on the outside is my power over all of that. Okay? So, the reason why I'm explaining this is because you need to be able to exchange between the two. You need to be able to take roots and turn them back into powers, or take powers and turn them back into roots. Okay? So, let's go ahead and look at some examples of these, and we'll start talking through some things. Oh, before I do that, just a kind of like little note that you need to understand. Anytime you have an even root with a negative number under it, this does not come out nice. It is not a real number. In fact, it comes out to be what we call a complex number, which we'll get to towards the end of chapter 5. Okay? But you need to understand that anytime you have an even root, like a square root, a 4th root, a 6th root, if there is a negative number underneath that root, your answer is not a real number. It does not simplify down. Okay? And then the other thing that you need to understand. Oh, look, right there. I even talked about it right here. Silly me for not scrolling down. So remember that an even root with a negative number under there equals not a real number. Also, the other thing to understand, and this is an exponent that we'll talk about a lot more in the next video, but it's a really easy idea, but somehow we mess this up. If you ever have a negative exponents, and you'll hear me say this all the time, they move. They either move from the numerator down below to the denominator, or they move from the denominator up to the numerator. Negative exponents move because they are not happy where they're at. Once you move them from the numerator to the denominator, they will become a positive exponent. Or once you move them from the denominator, to the numerator, they will become a positive exponent. Okay? And one more little piece of information. These are two different ideas. And the first one, this is -1 times that number to an a. And the second one, this actually means you have, whoa, crazy things going on. This actually means, in this guy right here, that you have a negative number to a power. So there's a difference between these two. Okay? This first guy right here, this is a -1 times a number to a power. And the second guy, the parentheses, let us know that that negative and number are together, which are being raised to that power. So that's super important. Keep that in mind as you look at these. Because these are not hard problems. They're very, very short and small. I have 5 problems that are right here that we're going to reduce down using what we talked about. Okay? So, if you remember this piece right here, 1 is the power, and 2 is the root. So all we're going to do is they want you to take a half of the 9 and a half of the 16. That is a half power, not divide the number in 2. Okay? So we want to take 9 to the half and 16 to the half. This is what I was talking to you about a moment ago. If you understand rational exponents, we can turn this back into what they really are. So what we talked about a moment ago, that the 1 is the power and the 2 is the root. So what we're looking at is we want to take the square root of 9 and we're going to raise it to the 1 power. Because the 2 was the root. The 1 was the power. Down below, we're going to take the square root of 16 because it's a 2 in the denominator, and we're going to raise it to the 1 power. Okay? So all we did was take it from the rational exponent into the radical, like what we talked about right here on this page. Taking it from the rational to the radical. So the reason why we did that is because we now know these answers. We know what the square root of 9 is. It's 3. And to the first power doesn't change it. So that really is just the number 3. We know what the square root of 16 is. It is 4. And again, if you want to raise it to the power that's on the outside of that 1, it's not going to change it. Okay? So there's the answer. This is what they're looking for. That is a simplified rational exponent. Okay? Let's do another one. Let's go over here and take a look at this guy. And hopefully you'll start picking up the fact that if you ever see a half, you're talking about a square root. If you ever see a third, you're talking about a cube root. If you see a fourth, you're talking about a fourth root. Hopefully you'll start picking up on that trend. So what we have here, notice the parentheses around the negative number. That means these two guys are together. So that means that we have a square root of a -64, and we're going to raise this to the 1 power. But again, raising anybody to the 1 power doesn't change the final answer, because anything to the first power is always just that number. Okay? So, what is the square root of -64? Well, if you remember what I just talked about a moment ago, I gave you this little, hey, please remember this, that if you ever take an even root of a negative number, the answer is not a real number. We are taking an even root. My root is a square root. That's even. We cannot take a square root of a negative number. So the answer is not a real number. Okay? So let's take a look at the next guy. This guy right here is a lot like what we just did right up here with the 9/16. But instead of a half, I gave you 2/3. So if I grab this guy, I'm going to go ahead and move him kind of over here to the side. If I take this guy, what they want you to do is they want you to take the 8 to the 2/3. And they want to know what is 27 to the 2/3. So again, thinking about what we talked about, the numerator is all about the power. So they want you to have the second powers on these. The denominator, which is 3, is all about the root. So we're dealing with cube roots. So what does this really look like? The cube root of 8, and we're going to raise it to the second power. Because my outside guy here is a 2, we're going to have to be careful because that's going to matter to us. Where before it was a 1, and I just talked about whenever this power is a 1, it doesn't change anything. But because this guy's a power of 2, you've got to do something a little extra in the end. So that's what the top looks like. In the bottom, you're taking a cube root of 27. And you're going to raise that to the second power. Okay? So, all we got to do is do some reducing. What number times itself 3 times gives you 8? That's 2. And it's to the second power. The cube root of 8 is 2. And then we've got this power out here that transferred along. What number times itself 3 times will give you 27? That's 3. And it's to the second power. So you see why I said these squares are important to us. Because in the end, I got to take these two answers that we took the cube root of, and I have to square them. So we get 2 squared, which is 4, 3 squared, which is 9, and that does not reduce. So there we go. Answer to 8 over 27 to the 2/3 is 4 over 9. Again, I'm going to grab my 25 to the -2, move it down a little bit so we can talk about it here in just a second. So over here, talking about this guy. I kind of spoiled the answer right over here if you were paying attention. All you got to do is turn this back into its 4th root of 16. So now all you got to do is think about what number times itself 4 times will give you 16. And that is 2. So 16 to the 1/4 becomes the number 2. Okay, so one more problem right down here at the bottom. So we got 25 to the -1/2. This is what I was talking about a moment ago. When you have negative exponents. When you have negative exponents, they move. So, where is this guy located right now? It is located in the numerator. Now some of you are going to be like, Mr. Armstrong, how do you know it's in the numerator? And the reason why I know it's in the numerator is because there's not a line above it showing me that it's in the denominator. If I wanted this in the denominator, I would have had to show you that. But you do not see that. So that means that this guy is in the numerator. And remember what I said a moment ago. What do negative exponents do? They move. So since this guy's in the numerator, where is it going to move to? The denominator. And when you move it, it becomes positive. It's happy now. And since there's nothing left in the numerator, we talked about this with rational equations, and when we were simplifying, if there's nothing left in the numerator, there's the number 1 that's there. So now that we've taken care of the negative, we're ready to take care of the rational. And again, you've already been seeing this guy popping up a lot. A half just means that what you're looking at is the square root of 25. 1 over that. And what is the square root of 25? 1 over 5. Okay? So, notice that in all these problems, anytime I had that rational exponent, I had to turn it back into the radical. And the radical help me do some simplifying. If I didn't turn it back into the radical, it would be, you wouldn't notice what should simplify. Okay? So, your turn. I've got 5 examples here, just like before. Give them a shot. Again, you're probably wondering where the 5th one is. It's right there. Okay, so let's start talking through this. So this guy up here is a lot like what we did a moment ago. You're going to end up taking the square root of 4 over the square root of 9, which gives us 2/3. This guy over here, your bottom number's 3, so that means you're working with the cube root. Your top number's 4, so that's your power. So when we look at this guy, we want to take the cube root of -8, because these two are together, they're inside that parenthesis, and then we're going to raise it to the 4th power. Now, this one has an answer. It's not one of those not a real number, because my root is odd. Because my root is 3, I can take the cube root of a negative number. Anytime we have an odd root, we can always take the cube root of a negative number. So what number times itself 3 times will give me -8? Well, that's a -2. Because a -2 times a -2 times a -2 is a -8. And we're going to raise that to the 4th power. So what is -2 raised to the 4th power? So -2 times -2 times -2 times -2, it's a +16. Okay? Again, the 27 over the 125 to the 2/3. It's a lot like what we just did a couple minutes ago. We want to take the cube root of 27, and then we're going to square it. Because again, that's the root. That guy's the power. And we're going to divide that by the cube root of 125, and then we're going to square it. Okay? So what number times itself 3 times gives you 27? 3. And we're going to square it. What number times itself 3 times will give you 125? That's 5. And we're going to square it. So all we have to do now is square those numbers. And 3 squared is 9. 5 squared is 25. Okay? Coming over here to this guy. Notice again, this negative is in the parentheses, so that means it's all together. If there were no parentheses, that means it would be a -1 times 16 to the 3/4. But we have parentheses, so that's all together. So here's what we're looking at. We're looking at the 4th root of -16 raised to the 3rd power. So, what are we doing here? Well, hopefully you notice that it is an even root with a negative number, so this is not a real number for an answer. Okay? So you got one more problem. Let's take a look at it. We got this guy right here. And again, we talked about what do negative exponents do? They move. Where is this guy located? It's in the numerator. Again, how did I know that? Because there isn't a line above it showing me that it's in the denominator. So, negative exponents move. So this guy, we're going to pick it up. We're going to move it to the denominator, and it's going to become positive because it's happy where it's at. Because I moved it out of the numerator and nothing was left, we put the 1 there. So all we're looking at here is 1 over the square root of 49, because that's what a half becomes. It is a square root. And what's the square root of 49? 1 over 7. Done. This is it. The last video for 5.2. After this video, you're responsible for all of the homework and all the quizzes. So let's talk exponential rules. And so in this, you're going to be applying some of those exponential rules. And we're going to be doing like some multiplying, some dividing. We're going to be doing some distributing and a little bit of factoring, like GCF style. Nothing crazy on the factoring. Okay? So first things first, let's talk about some exponent rules. And here they all are. These are all the exponent rules. Feel free to copy these down. So very important to understand, the first rule is that any exponent to the power 0, the answer is always 1. So it can be Mr. Armstrong to the 0 power, 1. 1 million to the 0 power, 1. Negative 50,526 to the 0 power, 1. Anything to a 0 power is 1. The next rule that we talked about right here, we've already talked about this. This is the negative exponent rule. Remember, negative exponents, they move. They move. So all that you're seeing there is if I have a negative exponent in the numerator, it moved to the denominator and is positive. If I had a negative exponent in the denominator, it moves to the numerator and becomes positive. Okay? So the next property that you see after there, if I have parentheses and you ever see a variable, or sorry, not a variable, if you have parentheses and you ever see a power on the outside, what they want you to do is multiply. In other words, this is like a distributive step. Multiply that power through the parentheses. The A multiplies the C. The C multiplies the A, and the C will multiply the B. That's what you're seeing right over here. With the with the X to the A times C and the Y to the B times C. Okay? And vice versa. I'm going to kind of skip down here and jump to this last guy. The same thing can happen if it looks like a fraction. That's what we were actually applying this in the last video. I just didn't tell you we were doing it. So if you ever have a variable, again, outside of parenthesis, all you do is just distribute it through to all the powers. Okay? So you get X to the A times C. You get Y to the B times C. Because it's just distributing through. Okay? Oh, also down here, kind of a good thing in this part, make sure that you convert all roots into exponents. So in the last section, we wanted to convert all exponents into roots. In this section, you'll want to convert anybody that is a root back into its exponent. Okay? Because that will make this thing a lot easier. And then last two properties, you actually worked with these two properties when we were doing scientific notation. When we had times 10 to a number, and we were multiplying that by times 10 to a number, you are actually adding those exponents, which is what was going on right here. These two get added. Okay? And just like when we were dividing scientific notation, we took those exponents and we subtracted them. Okay? Woo! Stuff's flying around again. So all these properties we've actually been using. Now we're just going to kind of like, talk about them. So again, when you're multiplying same base, and that's the big key for this guy, when you're multiplying the same bases, you just basically do some adding. When you are dividing the same bases, you will do some subtracting. Adding. And then, of course, you just saw this a moment ago, like we talked about. Again, this is all just multiplying because you're distributing through. So if you notice, there's only three things we do when we're dealing with exponential properties. We are either going to distribute, like what you see with this guy right here, and this guy right there, which is multiplying, or you're going to be doing some basic adding or subtracting. Okay? So let's do some problems. I've got 5 problems, and then I got 5 problems just like them for you to try on your own. Okay? And that will end out 5.2. So, I accidentally clicked some extra stuff. So what do you see here? Well, I have an exponent outside of a parenthesis, so that means we just need to go through and multiply. Let your calculator do the multiplying of the fractions for you. If you are multiplying these by hand, although it's not hard to multiply by hand on these, just be careful. But let the calculator take care of that for you. So if I actually multiply these, I actually get x to the 1/6. And that's it. That's all they want you to do. We are just applying those exponent rules that we just talked about a moment ago. Okay? So let's move to the next guy. All right, so again, kind of like my little notation didn't come through, but that's okay. Easy fix. So this is that reminder that I told you about. If you have roots, we need to fix them. Okay? So, what does this guy look like as an exponent? Well, the power on the x is 1. The power on this x is 1. So if I convert this into an exponent, I get x, the power goes on top, the root goes on bottom. And then we're going to multiply that by the other x, which the power of 1 goes on top, the root goes on the bottom. Okay? So there we just talked about converting from roots back into exponents. And that's how you do it. The power goes on top, the root goes on the bottom. Okay? Just like when we broke it apart to make the root and then the power. So, since these are the same bases, all we have to do is take our powers and add them. So, if I take 1/3 plus 1/4, I get 7/12. Again, let the calculator do that work for you. Go to your calculator, alpha y equals, put in the 1/3, then hit the plus sign, go back to alpha y equals, put in the 1/4, and it will kick out 7/12 for you. All right, the next guy. This is just the division one that we did. Because they are the same base, I can take these powers and subtract them. So again, I just go through and I let my calculator do the work. 1/4 minus 3/4 ends up being -1/2. And we talked about this already. What happens with negative exponents? They move. Where is this exponent right now? It's in the numerator. So it's going to move to the denominator and become happy. And since everybody's gone out of the numerator, we put the 1 back there. And that's the answer. Okay? All we've done so far is multiply when we had to distribute through a parenthesis, like on this guy. That's multiplying. We're distributing. We did some adding when we were multiplying, like bases. We did some subtracting when we were dividing, like bases. And now we're going to talk about distributing, and then I have a factoring problem. And again, the factoring problem is just a GCF problem. It's not too bad, and we'll work through it. So here, all they want us to do is to distribute this through to everybody. Now, this is a little bit different than before because I'm not taking a power through, I'm taking a variable through. And since I'm taking a variable through, what this really looks like is x to the 1/3 times x to the 4/3. Well, what do we do in this case? We take these powers and we add them. So we get x to the, sorry, had to grab my notes real quick, 5/3 here. Okay? Then, if I take the x to the 1/3 times the -2x, it looks like this. X to the 1/3 times -2x, and there's a power of 1 there. All I got to do is take my exponents and add them. Sorry, I got to move this guy down a little bit. So that gives me a -2x to the 4/3. Because again, I'm just going to let my calculator do that. 1/3 plus 1, 4/3. And then the last guy that we have x to the 1/3 times x to the 5th. Again, let your calculator do the adding. And that will give us plus x to the 16/3. And nothing gets together because none of these variables are the same. X to the 5/3 is not the same as x to the 4/3. X to the 4/3 is not the same as x to the 16/3. Okay? So that's it. It was just distributing. And when you distribute through, you're going to add those powers. Okay? So one more. This is the one where they want you to pull out a GCF. And the directions will just say factor this. Okay? Remember that when you pull out a GCF, you are always pulling out the smallest exponent. So all you have to do up there is find the variable that has the smallest exponent, and we're going to pull it out. Okay? So who's my smallest exponent? this guy. So we are pulling out x to the negative 2/5. Okay? So if you kind of remember back here, when we distributed through, it was all about adding exponents. But when you factor, you are undoing distributing. So instead of adding exponents this time, you are undoing that, which means you're going to subtract exponents. So I'm not doing anything to the 1/2, but I'm taking this guy out. So what is negative 2/5 minus a negative 2/5? Nothing, it's gone. And again, you should understand that because I'm taking out the same guy. If I'm taking out the same guy, both of these are the same, there's nothing left of it. So then I have plus 3. Now, I'm taking 3/5 and I'm subtracting a negative 2/5. Sometimes it might help you to write this out to the side so you see what's really going on. This negative is because of my number negative 2/5. This is because I'm subtracting. So when you subtract those, you get x to, you just get x, sorry. Because 3/5 minus negative 2/5 ends up being 5/5, which is 1. If you want to put the 1 there, you can. And then last but not least, we're taking negative 1/5 and we are subtracting negative 2/5 out. We didn't do anything to the negative 1/7 in front. We're just messing with the variable. So in the end, we get negative 1/7 x to the 1/5. There it is. All we did was pull out the smallest variable and subtract those exponents, figuring out what was left. Okay? Now it's your turn. I've got 5 problems, just like the ones we did. We're going to go piece by piece. So, try it. So, all you have to do is multiply these two. Okay? And that gives you x to the 1/20. And there's your answer. Try it. In this one, all you have to do, add those two. So if I take 2/7 plus 1/3, I get x to the 13/21. All you had to do was add. This guy. So here I gave you roots. So you need to convert these. And guys, if you ever see a root that doesn't have a number here, it's always a square root. We don't have anything called a 1 root. That's just weird. Okay? So if I convert these, I get x to the 1/2 on top, because that's what a square root looks like as an exponent. And I get x to the 1/3 on bottom. All I have to do is take these exponents and subtract them. So in the end, I get x to the 1/6 when you actually subtract those two. Now on to the distributive property, or the distributive problem, and then you'll have the GCF problem. Try this. Think FOIL. All right, so again, in this idea, when we are foiling, which is like distributing, we're just adding exponents. So what is x to the 1/2 times x to the 1/2? We just add 1/2 plus 1/2. So hopefully you know that that is x to the 1st. What is x to the 1/2 times 7? Well, that's 7x to the 1/2. So that was first. That was outer. Inner. What's 5 times x to the 1/2? 5x to the 1/2. And then last, what's 5 times 7? 35. And like any FOIL problem, sometimes you might have to put like terms together. So what do we get in the end? X to the 1 plus 12x to the 1/2 plus 35. And there it is. One more problem. GCFs. Try it. All right, so what is your smallest power? 1/3. So that's what we're pulling out. So what do we have left? Because I'm pulling this exact guy out, I only have one left. And remember that when we're dealing with this, if you want to actually work it out, you're just subtracting exponents. So what I would be doing there is 1/3 minus 1/3. Okay, now when I get to the next guy, I'm going to take 7/3 minus 1/3. And when I subtract that out, I get x to the second. And that's all we want. That's all we want right there. Just pull out that GCF. So you are now responsible for all of 5.2. Complete the homework, complete the quiz.